topic of today's webinar is phantoms, and we have two speakers who will guide you through the X-ray QA imaging. Welcome, Patrik and Martin, and also our audience today.
Hello everyone, and a warm welcome to you, Martin, from Diagnomatic. So we receive questions from time to time about phantoms. What are they? How do you use them? And so on and so on. So we thought it was a good idea to do a joint webinar together with the manufacturer and the expert of phantoms, namely Diagnomatic. So, Martin, who are you?
Well, my name is Martin Dahlin, and I'm the sales director for Radiography. And I'm so happy and proud to join you at RaySafe here today to talk a little bit about phantoms and the products that you sell.
We are very happy to have you here. So for today's webinar, we will try to go through the purpose of phantoms and also go through the phantoms in the RaySafe portfolio. So Martin, would you please tell us the purpose of phantoms? Why do we have them?
Phantoms are special tools we use in medical imaging to mimic human tissues and organs. They're essential for quality assurance measurements. These tools help us calibrate and test our imaging systems, ensuring our machines produce accurate and reliable images. Phantoms play several key roles. They help us check and adjust the performance of imaging devices, looking at things like resolution and contrast. When we make changes to a system or compare different systems, phantoms ensure image quality remains high and consistent. There are different types of phantoms. Some are anthropomorphic. That was a difficult word to learn. That means that they look like human anatomy, such as models that mimic tissues and organs. These are useful for simulating how human bodies interact with imaging devices, providing realistic data for quality assurance. Other phantoms are simpler and don't resemble human bodies. These regular phantoms are still vital for testing and calibrating imaging equipment. Whether anthropomorphic or regular, phantoms are crucial for maintaining high standards in medical imaging, ensuring accurate diagnosis and effective patient care.
But today we're only focusing on the technical phantoms, right? Not the anthropomorphic ones.
Yes. Technical phantoms are designed to provide consistent and controlled conditions. This helps ensure that imaging systems produce accurate and reliable images. They are used to check various aspects of imaging devices, such as resolution, contrast, and overall performance. By using these phantoms, we can verify that the machines are working correctly and maintain high standards of image quality, which is crucial for accurate diagnosis and, correct patient care. Imagine if a machine hasn't been properly tested and it produces a mirrored image showing the left as the right side. This simple mistake could lead to serious consequences. If a radiologist mistakes one side for the other, they might diagnose or treat the wrong area. For instance, if a tumor appears on the left side, but the image shows it on the right, the treatment could be misdirected, potentially harming the patient and delaying the correct treatment.
That's awful thoughts. We have all heard about patient getting the wrong foot amputated or things like that. So you must surely have the right tools to understand left and right.
Absolutely. And just looking at one of the simplest tools you can build is just a canister that's half filled with water and has a handle on the side. Think of it this way. The cap represents the head. The handle is like the left or right arm. The bottom of the canister stands for the legs. The water-filled part simulates the back, and the part with air represents the front. When ensuring quality assurance and using phantoms for testing, we follow various norms, standards, and recommendations. Key organizations like the AAPM or the IEC provide these guidelines. They offer detailed instructions on using phantoms to calibrate and assess imaging devices. These standards ensure procedures can be reliably replicated across different settings, maintaining consistency in imaging quality. They cover aspects like phantom types for different tests, testing frequency, and acceptable performance ranges. Additionally, these recommendations provide best practices for QA programs, including guidance on documenting and evaluating phantom test results. By following these norms, we ensure high standards of image quality, which are crucial for accurate diagnosis and optimal patient care.
Sorry for interrupting you here, Martin, but I find this slide quite confusing and overwhelming, to be honest. And in my experience, how hard you lean on this different type of legislation and norm can vary quite a lot from country to country, from function to function. in some countries, the regulatory body push down the responsibility down maybe to the hospital, the physicist, while in other countries the regulation is very strict and formulate everything that you need to do. So what's your experience there, and how should we work around these differences around the world?
Well, you're absolutely right. And it's crucial that you understand what the regulations are in your country. In some countries, as you say, the authorities will tell you in detail how to handle your QA. Whereas in other countries, you will have to have a QA system, but you can design it more or less as you want.
And that makes it quite hard, right, to design the phantoms that will work globally, because it varies so much between regions and countries and functions.
That is very true. And it's one of the obstacles or challenges we face. In the medical field, phantoms are objects that are scanned or imaged to test, calibrate, or troubleshoot medical imaging devices like X-rays and CT scanners. Some are designed to simulate human tissue, but all are built to provide a consistent, known model that can be used to ensure that the machines are producing accurate and high-quality images. While there are established guidelines for mammography and CT, there is a lack of uniform standards for radiography and fluoroscopy. Because of this, many hospitals and medical physicists have to establish their own routines for testing. These routines can sometimes be driven by country or state regulations. The most important aspect is how to develop repeatable and reliable tests. These tests are procedures used to check that the output of a diagnostic imaging system remains constant over time. Consistent image quality is crucial for the accurate diagnosis and monitoring of medical equipment. This emphasis on quality assurance in medical imaging is critical for patient safety and the effectiveness of medical diagnostics.
Sure was a lot to digest for the last 2 slides here, but let's leave the world of regulation for some time and focus more on the phantom, the RaySafe phantoms, and the ones we have in our portfolio and how we group them.
There are a variety of phantoms specifically designed for different X-ray modalities, and I will go into more detail for the different phantoms in the RaySafe product portfolio. The RaySafe portfolio has phantoms for radiography and fluoroscopy, for mammography, and for CT. The RaySafe Pro Digi is a classic radiography phantom. It covers most needs for digital radiography. It complies with both IEC norms and D norms.
We actually have the Pro Digi Phantom here, so you can see the size of it. And it's quite heavy, isn't it?
It is. It's copper inside, for example, so it's hard to get away with all the weight.
And you also mentioned the DIN standards. Those are German standards, right? But used globally.
They are for sure used in Germany and neighboring countries, but yeah, also around the world.
Okay, but let's focus a little bit more on the Pro Digi Phantom.
For sure. So here is the Pro Digi Phantom as it looks to the eye and how it looks when it's being X-rayed. The RaySafe Pro Digi Phantom is also equipped with a specialized holder designed to accommodate wall-mounted X-ray, ensuring accurate and reliable positioning for diagnostic imaging. Some tests need to be performed with an object that simulates a patient's body position between the tube and the detector. Certain X-ray devices feature a slot for filters located directly beneath the tube. For devices without this slot, we can use a filter stand. These pictures show ways of mounting the patient equivalent filter.
And the filters here, it is aluminum, right?
It is. When it comes to the patient equivalent, that is an aluminum, 25mm aluminum filter.
Perfect.
This slide here shows the different tests we can perform. They are central beam perpendicularity, dynamic range, spatial resolution, low contrast resolution, homogeneity, and collimation and beam alignment. This is again the test that we do with the Pro Digi, but we show the X-ray image of the phantom. Now let's take a look at the different tests. The first test is central beam perpendicularity. If the white dot in the center of the image fits within the inner circle, the perpendicularity is off by less than 1.5 degrees. This accuracy is achieved by the ball placed at the top of the cone and the ring at its base. Please note that the cone is delicate and may be easily damaged.
And this is how the cone looks, and this is how you screw it on the phantom, like this. But we receive questions from time to time about this particular test, Martin. Just from my understanding here, so what you're saying is if the dot you have on the X-ray image, if it's within the inner diameter of the circle or just barely touching it, the inner diameter of the circle, then we are on the safe side. Then we have less than 1.5 degrees.
That is correct, and that is how the test is done.
Perfect.
Then number 2 is dynamic range. Dynamic range is evaluated using a copper step wedge with 7 steps of varying thickness. Test number 3 is spatial resolution, or sometimes called high contrast resolution. Using the zoom tool, assess the high contrast spatial resolution pattern in the relevant part of the image. The corresponding line pairs per millimeter values are specified for each bar pattern. Test number 4 is low contrast resolution. For low contrast resolution, determine the number of visible low contrast objects. These holes, the objects, are drilled to different depths. Number 5 is homogeneity. In this test, we focus on examining the central area of the phantom image. Why the center, you might ask? Well, it's because this part doesn't have any test objects, making it perfect for measuring the signal to noise ratio. Now, what are we looking for here? Artifacts. Any inconsistencies or irregularities are unwanted. Test number 6 is collimation and beam alignment. This involves measuring the distance between the edges of the light field, represented by corresponding markings visible in the phantom's image and the edges of the X-ray field. We'll need to measure in both directions, perpendicular and parallel to the anode-cathode axis.
You sure can do a lot of different tests with this phantom. And I guess in the earlier days, you used to have like standalone items for every single test, while now you can do or have one phantom for all the tests.
And in some countries, as we talked about different standards being used in different places around the world, they still use all the different small tools separately.
Wow, they need to buy a Prodigy then.
They sure do. The RaySafe Pro Fluoro 150 Phantom is designed for quality control testing of both analog and digital radiography and fluoroscopy systems. Here, this slide shows all the things that are included when you buy a RaySafe Pro Fluoro 150. With this Phantom, we can perform collimation and beam alignment tests. This Phantom also allows you to test high and low contrast resolution. The Pro Fluoro 150 Phantom consists of a pattern of a grid and circles. Most of the test elements are placed in the central circle, which is very helpful when testing fluoroscopy units.
So what you're saying is that this Pro Fluoro 150 is very similar to the Prodigy, but this has a wider use or wider range because you can also use it on a fluoroscopy system.
That is correct. So if you have the intention to use it on fluoroscopy units, or you might in the future, I will go for the Pro Fluoro 150. If only radiography, the Prodigy is sufficient.
It's good enough.
Yes. When it comes to the 3D tests, we test things like spatial resolution of a 3D image, homogeneity in a 3D image, noise in the 3D image, and artifacts in, again, the 3D image. The RaySafe nested adult head and body CT-DI Phantom is used to calibrate and measure doses from CT scanners. It is made from PMMA, 150 millimeters, which very well represents the human body. The Phantom has an outer cylinder, which is 320 millimeters, which represents the human body, and 160 millimeters, which represents the human head. The Phantom is used for CT-DI measurements, which is one of the most common ways to measure dose on a CT machine. The PMMA on the Phantom is frosted and equipped with white positioning lines, which makes it easier to position the Phantom. The Phantom comes in a storm case, along with a cutout, which fits the RaySafe X2 base unit with RF detector and CT sensors, which makes a very good solution when you go out to measure on CT machines. There is also a GE adapter, which is a fixture to help you position the Phantom easier on GE machines. This slide shows the RaySafe Pro CT dose Phantom. For some applications and according to some regulations, you need a 3-piece Phantom. The smallest part then represents a pediatric head.
And you mentioned earlier about CTTI measurements, and for today's webinar we will not talk anything about CTTI measurements. But I do recommend you going to the RaySafe webpage, where we have a whole dedicated webinar about our CT sensor and how you do the CTTI measurements.
The RaySafe ProMam AEC BR Phantom is used in mammography quality control, specifically for testing the automatic exposure control feature. AEC ensures the correct exposure for the best image quality while minimizing the dose to the patient. The Phantom is made of tissue equivalent resin, simulating the X-ray attenuation of actual breast tissue. It mimics a balance of 50% glandular and 50% adipose tissue, important for accurate AEC adjustments. This Phantom complies with ACR recommendations. Using the RaySafe ProMam AEC BR Phantom, technicians can verify that the mammography system provides the correct exposure for each patient's breast tissue composition, crucial for early detection and accurate diagnosis of breast cancer.
Perfect. That was all of our Phantoms. But we also have some test tools and other equipment that could be useful when evaluating the X-ray machines. Right, Martin?
Absolutely, and I'll be happy to tell you a bit about them right now. So now we will take a look at some other test tools that are offered by RaySafe. We have test patterns, slit cameras, pinhole assemblies, and finally the Pro Stand. I will start by talking a little bit about focal spot and focal spot characteristics. Some might think of a focal spot as a point with no dimensions. In fact, it's an area of the anode where the electrons from the cathode are stopped and X-rays are created. As you can see on the image, the penumbra, or the blurring, highly depends on the focal spot size.
So how do you know the focal spot size on your machine?
Well, this is simply specified by the machine producers, so you can find it in the specifications on your machine. With time, the focal spot might degrade, so we have to measure its size to be sure of the quality of the image. We have two different tools that can do this, the RaySafe Pro Slit camera and the X-ray pinhole assemblies. Since we know the width of the slit, the enlargement factor, and we can measure its slit image size, we can then calculate the focal spot size. Two exposures should be made with the slit 90 degrees apart. Here's how you use a pinhole assembly to measure the focal spot size. The setup, you position the pinhole assembly between the X-ray tube and the detector. The pinhole is a small aperture, typically made of a high-density material like tungsten, that allows only a narrow beam of X-rays to pass through. Then the aligning. You align the pinhole precisely at the center of the X-ray beam. This step is crucial to ensure that the X-ray rays passing through the pinhole create an accurate image of the focal spot on the detector. Exposure. Perform an X-ray exposure. The X-rays that pass through the pinhole form an image of the focal spot on the detector. Because the pinhole only allows a narrow beam through, the resulting image is a magnified representation of the focal spot. Image analysis. Analyze the captured image. Measure the dimensions of the focal spot image. Since the image is a magnified version, you need to account for the magnification factor. The magnification factor is determined by the distances between the focal spot and the pinhole and the detector. Calculation. Calculate the actual focal spot size using the measurements from the image and the known magnification factor. This gives you the dimensions of the focal spot on the anode.
Is there a reason why we have two different methods here? Why can't we just use the slit for measuring the focal spot size? Is there a need for a pinhole as well?
I would guess it's somewhat a question of preference, what you prefer. But for example, the slit can be used for all sizes of focal spot. When it comes to the pinhole assembly, you need to buy the correct pinhole assembly for the size of your focal spot.
Okay, but one advantage with the pinhole is that you only need to take one or make one exposure. while on the slit you need to do 2 exposure for evaluating the...
Yes, exactly. The RaySafe Pro Stand is a holder designed to facilitate the positioning of the RaySafe Pro Slit camera and pinholes, which can be used for manual half-valley layer measurements or HVL measurements.
Yeah, and of course if you have an X2, there's no need to do this manual HVL measurements. There you get HVL by a single exposure.
Unless you're old school and you do like your filters.
Fair enough.
The basic version of this stand offers adjustable height ranging from 350 to 600 millimeters and an adjustable horizontal position. It is supplied in a cardboard box with a fitted inlay. The full version includes all features from the basic version and adds the ability to tilt it 10 degrees. It also includes a positioning tool for easy setup. The full version of the stand comes with a heavy-duty case for safe transport. Now we move on to the test patterns for high contrast measurements. If you remember, these were also included the Pro Digi and the Pro Fluoro Phantom. Line pairs refer to pairs of alternating dark and light lines used to test the ability of an imaging system to distinguish fine details. These are typically measured in line pairs per millimeter, with higher line pairs frequencies indicating better resolution. This means the system can distinguish between smaller details, which is crucial for accurate diagnostics. In radiology QA, line pair phantoms are essential tools. They help assess the spatial resolution of imaging systems by observing the smallest line pairs that can be distinctly imaged. Regular use of these phantoms ensures consistent monitoring of equipment performance, detecting any decline that might indicate the need for maintenance or calibration. These phantoms can look different, but all essentially have the same function.
And this was the last slide of today's webinar. Thank you so much, Martin, for coming here and teaching us and the viewers about phantoms and how they are used. Now it's time for question and answers. And in addition to Martin, we also have a technical expert on the line from Diagramatics who can help us with the more technical questions.
Thank you, Patrick, for announcing the Q&A session. With this, I'm opening up this part of the webinar by also welcoming Dr. Rafal Katarzyński. He is the co-founder of Diagnomatic. We encourage you to stay on with us and send your questions to our experts here today. Let's start with the first question. Why don't you have just one phantom which can do everything?
Do you think is this for Rafal, Martin, or would you like to take it?
I'll leave it to Rafal for an easier start one question.
Hi, welcome. So it's like a generic question, but it depends on the modality you are testing. Usually, each modality requires a different test of tools. For each modality, you have different tests that you have to perform, and not all of them can be fit into one phantom. I remember there were like attempts to do like a one universal phantom, but it's very saying if something is for everything, it's usually doing nothing. So that's the reason why we have some phantoms that are doing some tests, but usually I think like at this moment we are on the top of the line, I would say, in terms of technology, what can we fit in one box, so to say. So it's a technical reason why we cannot put everything in one phantom, but also it's like a technology, it's also like methodology of doing tests, but we just cannot do it for the test to make sense. I don't know if it's a good answer.
And worth remembering is also that the regulations vary from country to country and region to region, and sometimes hospital to hospital. So that's also a reason for the diverse flora of phantoms.
Okay, thank you. How do I know which phantom my customer needs?
Rafal?
Should I take it? Yeah. So I think the best way is to ask, right? You can ask us. You can ask guys at RaySafe. You can ask us directly at the Diagnomatic, and we can advise you what you should be doing. But usually, the best way to do it is to check with your local regulations, because as we were mentioning before, everything it depends on the country. In Europe, we mostly have like our regulations are like very similar country by country, but when we go to Asia, when we go to Americas, it tend to differ. So we can point you in the right direction. Usually our RaySafe test tools or our phantoms were usually designed for certain modalities, so it like narrows it down to a scope of products you should be looking at. But when it comes to fulfilling your local regulations, it's best to consult with regulators in your country. But as I said, like usually our phantoms are even named in a way that points you in the direction of modality they are testing. Like if you have RF, it means radiography fluoroscopy. If it has the word mam in it, it's usually mammography, and so on.
Right. And here's another one. With the ProSight camera on mammography, how to know how to position the phantom, the distance from the breast wall, and angulation.
It's exactly described in the manual, but the tricky part of doing tests in mammography is the angle between like if you have radiography unit and the table, the beam is usually perpendicular. It's always perpendicular to the table, so it's easy to position a slit camera there. But in terms of focal spot measurement in mammography, we have the lamp is at usually around 3 degrees angle. So that's why like we have this special stand that Martin showed you that allows you to tilt the measuring apparatus a bit to achieve this perpendicularity between focal spot between slit, focal spot, and the image receptor. When it comes to like what kind of distances we should use, it depends what kind of magnification we want to achieve. So it's I don't remember like manual by heart, but this can be like checked in manual what kind of distances we are talking about. But usually we need to it's like geometry, right? So we have camera if it's pinhole or is it slit, it always works on the like a camera obscura, right? So first idea of cameras that were designed, and this is the similar principle of enlarging the image of focal spot using camera obscura or slit camera to then measure, and depending on what kind of distances we set, what kind of magnification we set, thanks to this, we use that magnification to measure the focal spot. It's like a very long explanation for this, but it's easiest to I don't even have means to draw something, right? It's very difficult to explain with words without using images, because like it's a lot about geometry. So I would refer you to the manual that we can send to you after the webinar and explain it to you in more details.
That sounds great, Rafal. And another related question here. Is it possible to use the ProSight camera on a CT, e.g. combined with a detector of a mobile X-ray machine?
Not really, because I don't know why we should do it. That's the first question. But the problem is that in cities we have gantry that is rotating. So the source of radiation is rotating. And as I said, like the idea of focal spot measurement comes down to like having this camera, right? But we have a focal spot on one end, we have very small hole or very small slit in the between it and the image detector. So if we will, theoretically it's possible, but we would have to we would have to stop the gantry first from rotating. Then we have to set it up like it's in theory it's possible, but we'll have to. I think it's like requires a lot of integrate, a lot of messing up with CT. We have to stop the gantry. We have to put it in a way that is accurate, because accuracy in focal spot measurements is very important. So we need to have that slit camera or pinhole camera in exact distance from focal spot and from image detector, and also in like in especially in special dimensions they also have to be accurately placed. So in theory it's possible, but I don't know why we should do it. But probably this is the job for service department. You probably have to like disassemble half of the CT unit to do it. In theory it's possible, right? But why? It's not something you normally do. It's not something you normally do, so you don't do that normally.
Okay. So I think the next question maybe would be to Patrick.
Finally, a question for me.
Yeah. Is RaySafe going to develop dynamic imaging phantoms, i.e., all static phantoms give incorrect results in the presence of recursive filters?
Well, maybe.
Tricky one.
Yeah, maybe I should say on this one. I mean, if the need from the market is big enough, then of course we gladly do a collaboration with Diagnomatic and try to develop something that covers your need, of course. So I'm not saying no. I'm saying that if the need is big enough, absolutely, let's investigate it.
What's the take on that, Rafal? Is this possible, or I don't know.
Like we have a saying that impossible things we do, difficult things we do for in few days. For impossible things, you have to wait. So like what was like our the idea, because the company was founded by me and my dad. Our thinking from the start was that you don't have to be but we have a saying in Polish. You don't have to be a saint to make um, to make things, right? We done a lot. We started with one product in 2007. Now we have hundreds of products in our portfolio, and doing anything is possible for us. It's less, as Patrick said, it's more of a need on the market, right? If there is a need on the market, if there is like a requirement, if customers want it, we will do it.
Perfect. Good customer thinking there. Good focus. So let's see if we have more questions for you. I encourage you to send in more, because we are getting to the end of the list now almost. So please do send them to us. If I need a phantom which is not within the RaySafe portfolio, what do I do? And that was quite close to the other one.
Yeah, I take that question as well, and it's very similar to the last question. I mean, if there is a need for a phantom that we don't have, then we are more than happy to closely work with Diagnomatic to see if we can find a phantom for that need, for example.
So I will give the audience a few more minutes to enter your questions in the questions box, and we'll just wait for you.
Doesn't look like all the questions been answered.
Let's see. We have one more here. Are there any phantoms for fluoroscopy CBCT work?
Yeah, all right.
If you have like fluoroscopy phantom, like fluoroscopy, radiography, mammography, those are, I would say, like two-dimensional imaging techniques, right? So basically, all of them come down to source, like focal spot being on one side and flat image detector on the other side, right? So for testing this kind of devices, you need two-dimensional objects. If you are talking about CBCT or CTs or MRIs, we are talking about 3D, right? So those are 3D techniques, and usually they involve, as I was mentioning before when I was talking about measuring focal spot of CT units, usually we have gantry or we have some other way. Partially in tomosynthesis, it's like similar, but you have movement of focal spot around the object. So it's rotating or it's moving around the objects to create 3D image. So to like acquire image in maybe not 3D image, but acquire volumetric image. So not only flat, but volumetric. We're getting information from a volume, not from only flattened surface, right? So the way how it works, it requires different objects. We cannot use two-dimensional phantom like ProFlu or Prodigy on we can use them, but, but we'll get no information, right? We will not get quite information because those phantoms are designed to evaluate two-dimensional imaging, right? So flat. Basically, they are flat. They will only test 2D, two-dimensional imaging devices. For CBCT, we need three-dimensional objects. That's why CBCT phantoms, CT phantoms, MRI phantoms, they are usually cylindrical. They usually have a shape of a cylinder because we are imaging them from all sizes, right? If you have like a gantry of CT, it's scanning them from all directions and produces volumetric image of the phantom. So in that sense, we cannot use two-dimensional phantoms on CBCT to get reliable results. We can use them, right? Who will stop us? But why? Again, why? We will not get information. That's why it comes down to, I think, first question, like why cannot we have one phantom for everything? That's another reason, right? We cannot measure something that is three-dimensional with two-dimensional object, basically.
Good. And the questions are coming in now. That's really good. So next one, are you able to loan phantoms for evaluation?
From RaySafe point of view, I see that it's very possible. That's a discussion you need to have with the sales representative to see if you can just borrow a phantom to see if it covers your need or something like that. So from our perspective, that is absolutely possible.
Good, great. So does the CT phantom offer the possibility to assess the quality of the reconstruction as well, similar to the X-ray phantom, but post-reconstruction?
We are only talking about CDDI phantoms, right, Martin?
Yeah.
No, we are not talking about images. Yeah. So no, those phantoms that Martin were presenting were only for measuring those. We have a product that is called ProCT and similar phantoms that are imaging phantoms for CT, and they can be used to reconstruct to test reconstruction, and also to test, like for example, like fitting between if you have hybrid systems, if you have CT with MRI and or like CT with Linux. We have phantoms of that, but the phantoms presented on the by Martin here, they were only for those measurements.
Right. So, what are the key features to consider when selecting an X-ray phantom for a specific application?
I would say like first, if it meets the like criteria test what we want to cover, right? If it meets all the requirements that are required by the government locally, by our government, or what we want to test, then probably pricing, probably like does it come with a software? Does it have like a warranty? Like basic like things that Patrick can cover, right? How it works with RaySafe meters and stuff like this. But basically, I think like the first thing that you should check if it meets if it will cover your requirements, your legal requirements, or like your local requirements, or like your hospital requirements, whatever. If it will serve your needs, if it's easy to use, and then how it works with the rest of the ecosystem, right? Because I always say you also always should look also on the like total cost of ownership of the quality assurance systems you are running.
Super. So we have another one here. Not the measurement of focus spot, but rather things like registration, etc. 3D imaging is very common now. Can RaySafe come up and invent a suitable 3D fluoro angio phantom? Much needed.
Well, we have the P3D Phantom, and I wonder if that covers most of the need, or if there is another need that we're not capturing here. Do you have any thoughts there, Rafael?
Yeah, yeah, I'm not sure, right? Like what could you repeat the question, right? Because I'm not sure really what was the like what we are looking for.
Yeah, I take it from the beginning then. Not the measurement of focus spot, but rather things like registration, etc. 3D imaging is very common now. Can RaySafe
Yeah,
come up with a suitable 3D fluoro angio phantom? Much needed.
fluo, 3D fluo. Yeah, so when it comes to imaging, right, for example, then P3 P-Flow Phantom will be like only for resolution, right? So if you want to test, but the requirements, like one thing is what we want to develop, right? What we can develop. The other thing is like what Martin mentioned, right? What drives the legislature, what drives the QA is mostly legislature, right? So the regulations and DIN standards at this point for fluoroscopy and for 3D, they only show us what we have at this moment. They show Fluo 150 and P3D, and that's what's covered. That's what should cover every test that's required for those devices. If we are looking for something more experimental and I'll call like more R&D projects. Of course, they are possible, but I don't know if it's how big is the market for that, right, Patrick? If it's like something that is required by regulations or just like customers are looking for to have some custom-made products. We develop a lot of custom-made products, right? But it's more a question of the need, right? What exactly you are looking for. If we get some more specification or some more information about like exact needs, we can look into it and maybe advise like, okay, we actually have product for that. Just it's maybe not in the portfolio of RaySafe, right? But at this point, as I say, like from like legislation point of view, this is what is like what was developed by standard authorities. Fluo 150 and P3D. That was like what what authorities, what standards are like giving us for these phantoms and in this modality.
Okay, so this could actually be the final question here today for the panel, but we'll see. How do different types of X-ray phantoms compare in terms of cost, durability, and realism?
Well, from my point of view, I guess it depends on how do you say it? How wide the range of the phantom is. If you have a more basic phantom with less test tools and everything in it, then most likely it will be cheaper. So I guess it depends on how much you can use it, the variety and the wideness of the usage. That's one thing. I'm not sure if you from the manufacturing side would like to.
Well, I would say durability, these are durable products. They will last a long time. Realism, they are not meant to look like human organs or human body parts. They are meant to give you a technical basis for doing an evaluation. So realism is it's a difficult thing to answer. They are realistic when it comes to what they are supposed to look like. Cost, yeah, it depends on what you need. What RaySafe offers is a very good cost compared to what you get. You get a lot of possible tests in those phantoms, and I would say at quite a reasonable price as well.
Well, I think we have another one actually. So, why RaySafe is representing only few phantoms from Diagnomatic, not all?
Patrick?
Well, yes. Well, once again, I guess it depends on the customer need, our customer base need. And in an ideal world, we can of course offer anything and everything. But well, it takes work for us to sustain the phantoms we have from Diagnomatic today. But as we have said several times during this session, that if there's a big need, of course, we can expand the portfolio.
All right, so I believe that this would conclude today's webinar, and I really hope you enjoyed our educational session. I would like to thank Patrick, the Diagnomatic team, and our audience today for your participation. Thank you so much.
Thank you.